full name and the last three digit of the roll number in the chat box. So that can serve as a attendance record. Okay.
Okay, sir.
I can just copy it and keep it as a text file. So just type in your full name and the last three digit of your roll number, unless you are a lateral entry student or a readmitted candidate. So for lateral entry student and readmitted candidate, please write your full roll number. In fact, today also I had to visit the university unplanned. There was a equipment that was being installed in the applied mechanics laboratory, and I had to visit that particular means to see the installation and the demo. Some of you might have seen me, right? I deliberately turned on the camera so that you can have a look at me. Not a very handsome face, of course, but okay, tolerable maybe. Okay, so in the last semester, you had been introduced to a subject of machine design 1, right? And I guess Shonjeev Acharya sir was taking your class. So
Yes, sir.
in that
Yes, sir.
particular course, so you were introduced to the basic design philosophy, like if something is to be designed related to mechanical system, how you need to proceed about that. So that basic design philosophies, then some theoretical backgrounds, some mathematical equations, theories of failure, a very vital part of machine design. So all these things you have been taught in the last semester, and I guess you have also had a test of design of a particular component, and the component I guess was quarter joint and knuckle joint. It was there in your syllabus, right?
Yes, sir,
Yes,
but
sir. Yes.
we have taught only quarter joint.
Okay. Anyway, so for quarter joint, you had got a test of applying your knowledge of machine design, means whatever basics of design philosophies and the theoretical backgrounds you got, means you imbibed. So the application of that for designing a simple component like machine, like your quarter joint, and also a widely at least at a time it was a very widely used component from the if I may talk from the industrial revolution days, means starting from industrial revolution 1. So right now we are standing at the juncture of not juncture, I would say. We are standing at a age when we are facing industrial revolution 4. So all started from 1, then there was industrial revolution 2, and each of the phases of this industrial revolution had some particular development in that particular period. So right now, for industrial revolution 4, you might be aware that this industrial revolution 4 is more about this big data analysis, this networking, smart manufacturing, your remote manufacturing, robotics, implementation of robotics in the manufacturing scenario. So all this is normally it is considered to be a development, but okay, introduction of robotics and automation in the industry leads to layoffs, means cut down of manpower usage. So that is another issue. So anyways, all are quite complex, but they're talking about simple terms. There has been always a gradual development in the industrial evolution, and machine design is more of like rather than, I would say, keeping it or referring it as a independent means referring it as a subject which has been developed independently. I would say that it is more of a byproduct of this industrial revolution, because as human civilization developed and as various needs came into existence, because unless there is some need, normally people won't take any action to solve a particular problem. Means first of all there should be a problem, otherwise there is people are living hell, means people are quite satisfied with their life, no problem is there. So normally in that scenario development normally doesn't take place. And so for a particular development, like I was talking about the industrial revolution, or even this development of a subject as machine design, there was some need in the background. Okay. So all this led to the development of various topics, I would say. Among that, machine design was one. Okay. So machine design, for machine design 2, I would say the prerequisites. Okay. So for a particular subject, there are some prerequisites, right? Otherwise, it is difficult to understand the subject. So for this machine design 2, there are some prerequisites, of course. So obviously, one prerequisite is the basic knowledge of this design philosophy, the theories of failure, so which you have been introduced to in the last semester. Apart from that, you require the knowledges you have gained from the strength of material subject, the strength of material, some knowledge from your engineering mechanics. So all this will be required while we talk about this design of various, means when we carry out design of various mechanical systems, which is actually will be facing in machine design 2. So in machine design 2, we'll be having some standard systems that we encounter in as a mechanical engineering means as a mechanical engineer in commonly. So those particular systems, how to what are the design philosophies for those particular system, because each system has a particular, means unique philosophy. So those things we need to understand. And for this common system, the common systems that will be seen in the machine design 2 and will be learning about them in machine design 2 will help us to develop means to develop or maybe to understand more complex systems, because the complex systems are developed from simple systems like bearing or your gears or your this rivets, this screw joint, bolted joint, and so on. Okay. So however, machine design 2 previously had this component as gears, but right now they have been shifted to machine design 3. So I have actually undertaken, I have taken courses of machine design 2 where the gears were there in the syllabus, but the syllabus has now been made slim and trim. I'll actually share you the syllabus so that you can see it. I guess you are able to see my screen.
Yes, sir.
And the
Yes, sir.
document that I am sharing. So this is the machine design 2 syllabus. Okay. You will find the syllabus in the JU website. So as you can see, the first part of this syllabus is related to the COs, course outcomes. However, these are right now not relevant to mechanical engineering because we are not following the NBA. These are all related to your NBA aggradation part. But fortunately, you tell, or unfortunately, our department has decided to stay away from this aggradation. So right now, this part is not relevant. However, the detailed syllabus is after that. So as you can see, the syllabus contains components. As I was talking about that in this particular course, you will be learning about the design philosophies of various common components that you as a mechanical engineer encounter. Okay. So here, as you can see, there are screwed joints. There are various joints. Among that, the bolted or screwed joints, the transmission screws. The transmission screws, if I talk about, they are actually referred to as power screws also. And transmission screws you will most commonly find in screw jacks. So you might have studied about various thread profiles like metric thread profiles. You are aware, right? Metric thread profiles, then Acme, then square threads.
Yes, yes.
So this Acme and square threads, this metric threads or V-shaped threads are normally used for fastening or bolting purpose. Okay. However, the Acme or the square threads are normally used for power transmission purpose. So that are this transmission screws. Okay. So those have some separate design philosophies we need to understand. Then riveted joint, then welded joints. So their design, how to design riveted joint and welded joint. So those are under design of joints. And then we come about design of shaft couplings. So shaft couplings are used for connecting two shafts for power transmission purpose. So shaft couplings can again be rigid and flexible. So those details we will be discussing when we discuss this particular topic. So design of shaft couplings, then clutches, your brakes. So clutches, brakes are very common components of automobile vehicles. So this automotive components, how the basic design philosophy or background we will try to learn. Okay. Then belt drive. Okay, belt drive are used for conveyance purpose. For first of all, belt drive is definitely used for power transmission purpose when the distance between two shafts are very high. Apart from that, they are also used for conveyance purpose, for shifting one particular object from one place to the other. So the design of that belt drive, then chain drive, those are also there in our syllabus. So if you talk about what to expect from this course, so you have to the expectation from this course is you will be learning the design philosophies of some elementary mechanical systems like these joints, this coupling, then your clutch, brake, belt, and chain drives. Okay, so this is our entire syllabus, and we'll try to address this. So till anybody has any question till now, or anything more anybody wants to elaborate about the course or anything, can tell me. Otherwise, I'm planning that I'll lightly start the first topic, and the first topic today I have planned is riveted joint, which is a very simple component. So mostly I select this component as the first topic. So anybody has any query or anything to say about? Any general comment you want to make? Shabai, everybody understands Bengali? Anybody is there who doesn't understand Bengali?
Yes, sir, most probably.
Means everybody understand, right? That is
Yes,
yes,
sir.
yes means for that. Okay, okay.
No, sir, not everybody. Abbas don't understand Bengali.
Abbas,
Yes, sir,
okay,
most of the students, except
Rahul,
sir, one,
most
two.
of the students understand
Except
Bengali,
one,
and
two.
and
Except
my
one, two.
means my delivery is normally based on English only, but since I am a Bengali speaking person, so sometimes Bengali comes. Okay, even though I
Yes,
will
sir,
try to.
they are just
So
one, two, three students who can.
yeah,
It
yeah, but
doesn't
I guess
matter.
what I will be talking about, even though if it is in Bengali, it will be understood by them, because mostly I'll be talking in English. So I guess not a problem. And for the people who are non-Bengali, if at any point you feel that I have told something in Bengali and you could not understand, please immediately ask me. Okay, I don't mind explaining that again. Okay, so anybody has anything to any further query regarding the syllabus or the course you could not understand, you could not get? I'll put this syllabus in the Google Classroom, which I have yet to make. Okay, I could not find, because I every day I'm visiting the university, and yesterday it was raining heavily. I got drenched totally. So once I find time, I will make the Google Classroom and share this syllabus, and subsequently all the classes and everything that will be recorded, the PowerPoint presentations, or everything I'll just share. Okay, so not a problem. And regarding the evaluation, even evaluation is a very tricky part, I would say, in this era of online classes, because the evaluation each and every day things and some new changes are being. But right now, according to UGC, I guess at the end, the end semester will be of 70 marks, and the intermediate test, actually intermediate test for us is the class test. Class test will be mostly based on home assignment mode. Okay, so I guess that is the thing I am aware till now. However, this may change. Okay, it may so happen that at the end we take 30 marks and 70 marks, means two separate exams at a single means phase. So that maybe there is a possibility of that, because the same thing happened in the last class. Last means the last machine design 2 class that we had in the last year. So there at the end, 30 marks exam and 70 marks exam, and two separate question papers were shared, and some time limit was there, and students actually submitted them back. So that was how the thing was carried out.
Sir, I
Farooq.
have a suggestion type of thing. Like I was discussing with one of my batchmates
Okay.
that it can be possible that when we complete half of the syllabus, you can take a 30 marks assignment. Then
Okay.
that can be evaluated for the 30 marks part, and the 70 marks will be the semester one, the whole syllabus, because it becomes very means what I will
Very
say.
huge means for you it becomes a huge load, right? Means
Huge load means two
because
questions per.
particularly that 30 marks, if I consider that 30 marks to be that means for the whole syllabus from any part of the syllabus, the question may come for that
Yeah.
30 marks exam. So that is a load for you, right? I can
Yes, sir.
understand
For
that.
30 marks, if we are if we are going for the full syllabus, then it will be like
Understood,
30
understood.
marks. मतलब 30 marks में क्या full syllabus से क्या ही
Yes,
question?
actually, it is better to take 100 marks test of the whole syllabus than taking a 30 marks and 70 marks different question paper.
Yeah, but the thing is, this entire thing is not
In
means
your hand,
yeah, in
exactly.
my hand and
Yeah.
not your hand, and this is part mostly governed by UGC. And
Yes.
then what happens is it comes to our means all the universities, and then universities then they modify the thing a bit based on the feedbacks, and finally they come up with a rule and regulation, and that we have to follow.
Yes,
But I
sir.
can understand that taking a 30 mark at the midpoint will be a better option, because I can also judge that how people are means
Responding.
getting my thing getting means how the teaching, rather how the teaching learning process is going on.
Yes,
So
sir.
that feedback also can be obtained if I can take a test at the
Yes.
mid part of the syllabus. Actually, last year what happened was, since no test was taken at the mid part of the syllabus, I independently created a survey in the Google form, because I wanted to know like whether the teaching learning process is going on correctly, whether the students are getting interested, whether they are able to capture what I am trying to convey. So for that, for my judgment, actually for my evaluation, you may tell, I actually created a short Google form and asked the students to give feedbacks regarding the teaching learning process, and students gave the feedback. So from that, I tried to actually change my lecture delivery a bit. However, it was not much possible, because last year also I had to visit the university a lot of time, and I'm not sure like what is the favorable time for taking the class. Is it because if I have to, this actually I was discussing with one of your CRs, and what I told him, that since our university is gradually opening, at least for us as faculty members, and since I have some running projects for which I have to physically visit the university, because I have to take the signatures of finance officer and various other things, other persons. So that for that I have to physically visit the university in the daytime, and if in the daytime I go to the university, it is not possible to actually maintain the class routine that you have been given. I guess in that the first class is on Monday first half, and then there are two coupled classes somewhere on Wednesday second half or Thursday second half, isn't it?
Yes,
So
sir.
that thing may be difficult if I go on visiting the university on like frequently visit the university, and that if I do that, then the time left is after I come back from the university during the evening time. Is the evening time suitable for you all?
Sir, actually means
Yes,
we are
I
actually
think there.
keeping Saturday and Sunday as a buffer day. Okay. Means
Okay.
buffer day, so that the things which are pending in the weekdays can be covered in the Saturday and Sunday. So means like that. So
Okay,
if
means
we
Saturday, Sunday, you will prefer that Saturday, Sunday, if it is possible, I can take
yeah,
a class in
you
the
suppose
morning, like that.
you support so suppose you yeah, in the weekdays you are means you are unable to take some 1 or 2 hours class, then you can
Mhm.
cover it in Saturday or Sunday one
But
day.
what is the preferable duration? Means duration means I would say what is the means which time of the day you want the class to happen? Means if is
Yes,
it
sir.
So
For most of the students in the class, the favorable time is in evening hour. That
evening
I can
only?
say.
Okay, okay,
It's
okay,
a
okay.
Yes,
evening
sir.
hours is a very
meaning will
time.
I
be
think
much
no
more.
one should have any problem with that.
No, okay, okay. Actually, I got a feedback that most of you are late risers in the morning.
Yes, sir. Actually.
Yes,
Yes,
sir.
And
sir. Yes, sir.
for you people maybe in the evening it is better. Okay, okay. Obviously there should not be any interference with other classes, because right now maybe you are relatively free, but after some time other teachers will also start taking classes. Anyway, we'll fix the things up, no problem. Everything cannot be planned beforehand, so we'll plan gradually, no problem. Okay, so anything else to tell, or shall I start the discussion of today's topic, that is the riveted joint? Okay, so let me start because none of you are telling anything. You are able to see my screen, right?
Yes, sir.
Yes, sir.
Yes, sir.
Are you seeing this Google Chrome, this thing which I am dragging in, this green color thing?
Yes, sir. Yes, sir.
Yes, yes, sir.
To hide it. Okay, hide notification. Okay, because it will hide the topic of the slide, heading of the slide. Okay, so the first slide itself shows you how the riveted joint looks, and you may be quite aware of these things if you keep your eyes open while you travel somewhere. So many your this metallic structures that you might have seen, these bridges, and even some heavy outposts. So those things also at the base or somewhere you might have seen this type of joints. And although sometimes people mistakenly think that they are all bolted or screw joint, but actually they are riveted joints. Okay, so these are all riveted joints, and riveted joint was once a very popular way of joining this plate type of components. I told once it was once a very popular. If you notice carefully, I told that it was once a popular way of joining. Right now, it is not, because gradually welded joints are replacing this riveted joint, because the efficiency of welded joint is more than riveted joint. Now, any idea about this efficiency? What do you think? I mean, till now you have not been, I guess you have not been introduced to a formal discussion on this efficiency of joint. But as a layman, or maybe some technicalities you have, because you are already a half engineer, right? Second year is already completed. So as half engineers, okay, what do you think that efficiency, when somebody tells the efficiency of a joint, what do you think it may be? Just
So
tell.
more the
Lifetime,
longevity of the joint
life,
with respect to the
lifetime or
Longevity of the joint. Okay,
lifetime.
one person on longevity, another person is telling lifetime. Okay, so I guess that is same, right? Durability, longevity, the life of the your joint. Okay, anybody else has any other perspective of this efficiency of joint? Anybody has?
The purpose of the joint should be carried out to
Purpose
keep
of
the
the joint means to keep the, suppose I am joining two
two
plates.
bodies together.
The two plates or two bodies or two parts should be kept joined. Means if when I use a particular joining technique, they should be joined properly. Maybe that are, I guess, what you are hinting at, isn't it? And that joint
Yes,
should be maintained for a long duration of time. Maybe the durability of the joint should be good. Is it what you are talking about, isn't it?
Yes, sir.
Okay.
Yes.
So let me just another perspective of this efficiency, and that is what is the formal definition of efficiency. Although I have a separate slide later on, but I think you will appreciate if I tell the efficiency of the joint right now. See, when you are able to see my hands, right? My face, my hands.
Yes,
Am I
sir.
in the view, right?
Yes,
Because
yes, sir.
this has some elongated view. I'm not sure, and I am not a vlogger, by the way, so I don't have that much idea. Okay, so suppose I'm joining two plates. Let me take some the help of some cardboard or paper. Yeah, okay. This is a invitation card. Okay, and this is some A4 size sheet. I guess you are able to see both the things. This is yellow color thing, and this is white. So suppose these two plates, okay, consider them as plates. These two plates are to be joined. So how to join it? How to join it? The most easiest way of joining it, without the help of any other third plate or anything else, is to provide an overlap. So I'll just like put overlap this a part of this yellow this card and this white paper. I'll just overlap, and on the overlapping section, I may rivet. I may make use of this rivet, or I may make use of bolted joint. So for that, what I have to do, I have to drill holes. First job is to drill holes. Please try to get a outlook means on this subject from practical point of view rather theoretical. Okay, so that will create more interest. Okay, try to get a practical perspective. So this is a plate. I have to join these two plates. So first, what I have to do is since suppose I am not right now not talking about welded joint. Suppose I am more worried about this riveted joint and our bolted joint. So for riveted joint or bolted joint, I have to make holes. Okay, so I make holes. Obviously, the holes should be as good as possible. As quality should be good. If I have, suppose I make 3 holes, the distance between the holes should be equal. Okay, so those things I'm maintaining. Similarly, on this plate also, I will make the same size holes situated at that same distance apart, such that when I make a overlap, because this is the simplest way of making the joint, right? So when I produce the overlap, I can match the 3 holes. I have planned 3 holes, so that 3 holes can be matched. Now, when these 3 holes, I align these 2 plates so such that these 3 holes are matched. So if you talk about the bolted joint, so what I'll do, I'll put the bolt or the screw at the 3 locations. I'll use 3 bolt or screws. Obviously, according to the diameter of the hole, maybe I have selected the bolt. You are aware of the diameter of the screw joints, right? You are aware of the nominal diameter of the screw joints. Please say yes. You are aware. Are you aware of the nominal diameter of what is nominal diameter of your bolted joint, screw joint, from machine drawing maybe? No.
Yes, sir. Outer dia.
Yeah, there are 3 dias if you talk about the screw joint. So the highest dia, if you talk with respect to the bolted joint, means if you talk with respect to the bolt or the screw, the highest dia that we encounter in the part, so that is the nominal dia, and with that only the bolt is specified. Okay, so suppose I select the proper bolts and I put the 3 bolts, and on the bottom side I put nut. So this is the most common way of joining, isn't it? So instead of bolt, I can make use of rivet. So rivet is also looking like the geometry is similar to bolt. So bolt, I can put the rivets and I can make the joining. Now I was talking about efficiency, right? So the efficiency is, suppose these 2 plates are to be joined, and this joining is required because I am not able to produce a longer plate. Suppose this is a steel plate, okay, stainless steel plate. So this plate is suppose limited in size. So better I'll take same plate. Yeah, same size sheet. That will avoid avoid confusion. So this plate is shorter in size because I have manufacturing limitation. I cannot manufacture lengthy sheets. So this sheet is this much size only, but I need the lengthier sheet. So I am using another sheet to join like this to make lengthier sheets. Now, due to this joining, first of all, please understand, due to this joining, I have created a weak point in this system. System means when I am joining these 2 plates, I create a small system, right? So in this system, the weakest point, I guess you will agree, is the portion where this is joined. That is this portion. Because when suppose I pull these 2 plates apart, okay, I subject these 2 plates to tensile loading. So obviously the most chances of failure will be through that joint rather than one of the plates failing from the mid or somewhere else. Everybody agrees, right? When I join,
Yes, sir.
because the weakest point is the point where it is joined. Because why it is the weakest? Please, anybody, some points why it is weakest? You know this. Why it is weakest?
Sir,
Stress will
because
be
the
maximum
area,
at that place.
So stress concentration increases.
Yeah. So there are holes. Then for that holes there are stress concentrations. Then I am using this rivets or this bolted joint, which may be of different material. We are not also maybe I cannot get higher strength or higher capacity bolt. So maybe the strength of the bolt, shear strength of the bolt or whatever is lesser than the this tensile strength of the plate. So this bolt may shear off, or the plate may tear off at those locations where these holes are there because of stress concentration. So a lot of things may happen. So all these things, one thing is clear, that when we pull these 2 plates, the critical area is the joining part, because that is the weakest link in this entire thing. Now, when we talk about efficiency, we have to think about what is the minimum load with which this joint may fail. First of all, we have to determine that load. what is the minimum load with which at which this joint will be subjected to failure. Okay, now that particular load, suppose I determine, so that is the minimum, that is the minimum load with which this joint will fail, and I write that value. And next what I will try to find out is what is the minimum load with which, if this two plates weren't two plate, rather I could have manufactured a single plate of this length, and one single plate continuously of this length. So in that case, same loading, what is the failure load? So obviously in that case what I have to do is I have to get the cross section. Everybody knows, right, cross section of this particular plate, and I have the suppose this material is stainless steel. Your strength is well known. You get the standard tensile stress values, your ultimate and yield. So those values are known. So from that values you multiply this particular cross section, and you get the maximum load or the failure load of this plate if they had been continuous. You are able to get it, right? So
Yes.
I get two loads. One is with the joint, and one is when considering there is no joint. So the ratio of these two, the ratio of the first load, that is with the joint, to the ratio of the means by the second load where there is no joint, is the formal definition of efficiency of a joint. Did you get my point? So one is when I make a joint, I create a weak point. So how much means what is the measure of that weakness? Okay, so that is actually we get from that ratio that I just talked about, isn't it? So that actually defines the your efficiency of the joint. So we'll talk about it in details in a slide. I have it anyway. So let us move forward. So some more examples, practical examples of this use of or application of this riveted joint. So this is a very common landmark. All the Calcuttans who have been born and brought up in Calcutta, so this is one of the landmark which in fact outside people also refer this as landmark for when they talk about Calcutta. So Howrah Bridge, famous Howrah Bridge, all the joints in this Howrah Bridge are riveted joint. Okay, none of them is bolted joint. So if you look about closely at a bridge construction, so this rivets are looking like this. So closely, next time you pass under the Howrah Bridge, you can look at the joints and you will see these rivets. Now, when I talk about the riveted joint, so let me at the very beginning tell about the types of joints that we encounter in mechanical assemblies. So broadly, the types of joint that we encounter are separable joints and permanent joints. So as their name suggests, separable joints are temporary joints which when required can be opened and dismantled easily. Permanent joints are difficult to dismantle. So for permanent joints, you need to inflict some damage. Unless you inflict some damage, you cannot separate them out. So these are two broad categories of joints that we use in mechanical assemblies. So this is the formal definition and some examples of separable joints. So you know that threaded joints, bolted joints, quarter joints, so they can be very easily dismantled without any damage, right? So these are falling under separable joints. Permanent joints are joints, as I told, that without causing any damage, you cannot dismantle them. So riveted joint, welded joint are all examples of this permanent joint. So now this is how a rivet looks. Mostly the structure is similar to your bolt or screw. Only the thing is there is no thread. In bolt and screw we have the thread. So that thread is not there. Apart from that, you see a head is also there. However, this type of head is not useful for bolted joint because I cannot get a grip in the spanner or screwdriver. So if you have this type of head in the bolt or screw, rather I would say this type of head is found in screws. you have a cut at the middle so that you can put a screwdriver. The screwdriver head can fit and you can turn it clockwise or anti-clockwise suitably. So in case of rivet, this is how it looks like. And if you talk about the terminologies of the structure of the rivet, so this is the thing. So this part is the head. Then the part which is cylindrical. So this cylindrical part also, if you carefully notice, particularly for this rivet, okay, particularly for this rivet, you see the cylinder is of a constant diameter up to some extent. After that, it converges to a smaller diameter. So the part where the diameter is constant, so that is referred to as body or the shank. And finally, where the thing is tapered, where the part is tapered, so that is known as the tail. So this is a typical example of a rivet. Okay, this is a typical example of a rivet, and how it is, how the riveting is done is explained in this slide. So for riveting, what you need to first do is, when you are first of all, rivet joins two plates. So you have two plates and you drill holes. Without hole, you cannot put the shank inside. So two equal holes has been drilled in these two plates. Next, what you do is you insert the rivet like this and make the whole system upside down. But when you make the whole system upside down, obviously the rivet will fall down. So to arrest that, what we have is, we have a backup die. This is known as the backup die. So some part is there which is known as the backup die, on which this rivet and the parts are placed like this, so that the rivet stays in position. And the backup die also has a cutout on the surface such that it can accommodate the head of the rivet. As you can see over here, the head of the rivet perfectly fits in that cutout the backup die has. Now once this thing is made like this, okay, but we have another die which is known as the forming die. So this forming die again has a cutout similar to the head of the rivet. So this forming die is put on the tail of the rivet, which is projecting out from the back side of, means other side of the two plates. And on, after putting this forming die, what we do is, with the help of hammer or some heavy equipment, heavy instrument, we make some hits on this. So due to this impact, what happens is there is plastic deformation on this tail, and obviously as the tail is put under a cutout which is having a hemispherical type of shape, so after the riveting is done, so this tail part also takes the shape of this head. So I guess I am having that picture. Oh, unfortunately I don't have. I should have put a picture where the other side is also visible. So I guess you could understand. First of all, I have this backup die on this two plates, and the rivets are put like this. The tail part of the rivet is on normally put on the top side, and on the top we have this die type of thing which is having a hemispherical cutout. So this hemispherical cutout is making contact with this tail, and on top of this this die, if we provide some hitting with sufficient force, so this tail part of the rivet undergoes plastic deformation and takes the shape of this hemisphere. So finally, when this is done, we take out the forming die, we take out the backup die, and obviously you can understand the two plates will now be held in position, because after this plastic deformation, the head, as you can see, is normally having the diameter greater than this than the hole, and obviously they will keep the two plates in position. So this is how the riveting is done. Now in this procedure, you have to keep some points in mind. The selection of this die is important, because when you make the hit, the this rivet should actually deform. However, this die should not deform. So one thing is to be is certain, that the die should be selected of a harder material compared to the rivet, isn't it? So the die should be of harder material, both sides, this side as well as this side, such that when this impact load is made, the dies don't undergo shape change, rather the rivet deforms. So that thing is to be kept in mind. So whatever I told actually is written over here. So step by step, rivet is inserted in the holes. Head is firmly rested against the backup bar. The other end is upset by hammering on a die. Now, this plastic deformation that the tail undergoes is also known as upset. So this upset terminology is also used for this type of plastic deformation process, as we see in this rivet. So this is upset. So the other end is upset by hammering on a die. So any doubt in this particular riveting process? Everybody understood, right? So one thing is for certain, that after the riveting is done, you may be unable to distinguish originally which was the head side and which was the tail side, because the tail side will also look similar to that of head side. So that is one thing you can understand. Any doubt in the riveting
Sir,
process?
I have a questions.
Yes,
Sir, I
yes,
have
please.
one questions.
Yes, sir.
Sir, which material is used generally make a rivet?
Yeah, that actually there in the means subsequent slide, like mild steel is there. Then you have some, first of all you should select the rivet material such that it is ductile in nature, because it has to undergo plastic deformation, isn't it? So mild
Yes,
steel
sir.
is a
Yes.
very commonly used rivet material. However, the selection of rivet material depends on the the material of the plate that is intended to be joined by that rivet. So suppose you are joining two aluminum plates, obviously you will not use mild steel rivet for that, isn't it? So for that, what you will use an aluminum rivet.
Yes, sir.
So that thing is also there. Okay, so depending on the plates that we intend to join, we need to select judiciously the rivet material, and rivet material is made of there are a lot of material candidates for this rivet. Rivets are made of copper, rivets are made of aluminum, rivets are made of mild steel, rivets are also made of various plain carbon steel which are ductile in nature, not very high with high carbon percentage, because high carbon percentage will lead to brittleness in the steel. So normally that high carbon content steel are normally not used as rivet material. Many times, I don't know you have experienced this or not, when I was a child, so there were some vendors who used to pass in the neighborhood, and they used to repair the various aluminum utensils, especially the the utensil used for cooking rice. মানে বাংলায় যদি বলি ভাতের হাঁড়ি, হাঁড়ি যেটা হয় সেই
হ্যাঁ,
that
sir.
the হাঁড়ি বা that utensil, that aluminum utensil, you over means as you go on using the utensil, what happens is, due to the when you normally when you have the utensil, you place it on a table or somewhere, so gradually there is wear and tear on the bottom side of the utensil. So what happens is, after some time there develops a some hole may develop at the bottom side of that utensil, and when a hole develops, obviously you can understand that it becomes useless. So you need to make a leak proof means arrangement such that the hole can be covered and it is leak proof. So for that that vendors, as I was talking about, what they used to do is, they used to have this aluminum rivets. Okay, so this aluminum rivet they would used to put at that hole and use this same process that I am talking over here right now. However, they did not use this second plate, because you can understand their intention there is not to join two plates, rather to cover the hole. So this, suppose you imagine that this single plate is only there and you make that same process, obviously this length of the rivet should not be this much magnitude should not be there. It should be of a lesser height, this shank portion. So suppose this top plate is not there and you just hit this and you deform this. So what happens is, this entire that part where that hole is there, that gets covered. Okay, in fact, due to the since the rivet was of aluminum, the head was also, means after this head and everything was formed, they hit it further, and this head they made as flat as possible, so there was no projection. So they hit it further, means after that riveting is done, they hit it further and flattened the head on both the sides, and finally you will see that the that utensil is perfectly okay for next use. So that I found that particular vendors when I was a child, but right now I guess they have vanished. And right now the concept is use and throw, right? You use, you throw, you buy new. There is the chance, this repairing of the existing things are gradually going out of our way of living. So that may be one of the reasons that we don't find those type of vendors nowadays. Any further question regarding the process?
No, sir.
Okay. So yeah, so there are some processes, various processes also there in this this riveted joint, while making this riveted joint. So if I broadly classify them, so they are hot and cold riveting. So what is hot and cold riveting? Cold riveting is is when the entire process that I just talked about is done at room temperature or ambient temperature. So that is cold riveting. Now, what is hot riveting? In case of hot riveting, what we do is we put this rivet in a furnace, okay, or we make this rivet red hot. We heat this rivet and we make it red hot. So as you can see, about 1000 to 1100 degrees centigrade. So you can understand that it becomes red hot. So in this red hot condition, the riveting is done. So imagine that this rivet is heated and it is made red hot, and in this red hot condition, this rivet is inserted like this, and the riveting is done. So what is the advantage of heating this rivet? The advantage of heating this rivet is when this rivet, subsequently this rivet will cool down to the room temperature, and when it cools down, what happens is there is shrinkage in the shank, isn't it? Because when we heat, the parts expand. When it cools, the part contracts. So there will be contraction. There will whatever expansion it experienced during heating, so that will vanish and it will contract. As the shank contracts, these two heads will firmly grip. These two heads will firmly grip the two plates, making the joint very tight. Okay, and this type of joints are very useful, particularly when we deal with fluid leakage. Means suppose this rivet is used in a system where some fluid is to be kept in a container in a pressurized condition. So there is chance of leakage. So that body of the container, suppose, is made by riveting. There are some rivets in the body. So that this type of rivets, this hot riveting, will help to contain that fluid and will prevent any leakage, which may happen if in case of cold riveting. Okay, so that thing is taken care of if we employ hot riveting. So as you can see here, same thing as I told, hot process, when it is allowed to cool, it shrinks, plates are subjected to compression, and the shank will be definitely subjected to tension. As you can understand, as the shank is contracted, contracts, the plates, it pressurizes the two plates, so the plates aren't allowing the shank to contract to its actual position. So in this process, the shank is subjected to tensile stress, whereas the plates are compressed. Everybody got the point, right? So apart from that, rivets can also be manual or machine. Machine riveting, when we do, so the systems are normally operated by pneumatic or hydraulic based systems. Okay, so I have some couple of videos I can just show you. Now rivets are also standard components. Standard, when I term something as standard components, that means you can readily buy them in the open market. So you go to a relevant market and you can directly purchase them. You need not manufacture this rivet. So when there is some standard component, so the size of that component is also standardized, isn't it? So that's why the standard size of the rivets are this. So this size are nothing but the shank diameter. The shank diameter is the diameter with which a rivet is specified. So suppose you want to make use of a rivet, and you as a design engineer, you found out that 20 mm shank dia will be sufficient for your system. So what you will do, you will go to the market and you will ask the shopkeeper that please give me 100 number of rivets of suppose mild steel. So then the shopkeeper will ask you what is the size. So then you can tell that 20 mm is the size. So he will understand that 20 mm means you are referring to that shank dia, and he will give you the correct rivets. Okay. So these are the rivet diameters. Mostly you need not remember them in the exam. Obviously you need to select from the standard this series, and this standard series will be given, so no need to memorize them. However, means having a look at the series, as you can see, very not very hard to memorize also. 12, 14, 16, 18, 22, so up to 24 there is 2 mm gap, then there is 3 mm gap, and then after 42 then there is 6 mm gap. So the highest size is 48 mm. Now this particular size of the rivet I have taken from, I guess, textbook by Bhandari, I guess. Okay, so Bhandari's Design of Machine Elements is the book from where I guess I have taken this series. You can also refer to that book. As I told, rivets are nowadays replaced by welded joints because welded joints are found to be more efficient compared to riveted joints. Now at this juncture, let me show you some videos. So first of all, let me show you the riveting process. These are all, I guess, I have downloaded from YouTube. How to rivet. Okay, let me just rivet. Yeah. So as you can see, this is the backup bar, as I was talking about. So this is having the cutout. This is the rivet that he is holding right now. So that, as you can see, the head exactly fits in the cutout, hemispherical cutout in the backup bar. Okay. And this is the that top bar on which I'll be hitting. I'll be making the impacts. So that also is having this similar type of hemispherical cutout. And obviously this is the hammer to make the blows. And this is the tongue, okay, which he actually, this is the pair of legs that he needs to attach with the help of this rivet so that this tongue can be utilized. Right now they are separated. So that is what he is planning to. So you see, he inserts the rivet, he fits the head on the backup bar. Now, what he is trying to explain, I guess, is this length is important because too much length of the rivet protruding from this side will create an issue. So the length of the rivet should be judiciously selected or made by means keeping in mind the this thickness of the plates. How much you need to keep the thing projected on the other side, so that you need to judiciously select. Okay. So initially he just makes some hits. Okay, now what he is doing is he is making use of hot riveting. So he had made the rivet little bit hot, but not red hot. Okay, another advantage of having the rivet red hot is when it is red hot, it is easily deformable. So that is another thing to understand. So one thing to understand why he is hitting without this backup bar is when he hits the rivet like this, there is some clearance in the holes, right? So when he hits the rivet like this, the clearance around the rivet are filled by the material of the rivet. So that is why he is hitting like that. And finally, what he is doing is he is putting this bar on the other side, this die, and is hitting. See, after the thing is hitted, means he has hitten it. So you see the tail is also looking like the head of the rivet. So, okay, he is doing it in a iterative fashion, so not in one step. But he also needs to take care that the two legs are sufficiently loose, because if by riveting they are so tight that they cannot be moved like this, so the tongue will be useless. So that also he is trying to. So finally he is actually cooled down, and this is how you see the riveting is done. Okay. Next, I'll show you this one maybe. Okay, this one.
Sir,
So,
I sir, I had one question, sir, in last video.
Okay, tell me.
Sir, you have said previously that the material of the rivet need to be selected according to the material of the plate. That is, it does not deform the plate itself. But here I have seen that when it was given to the furnace, the rivet was also red hot, and the legs of the tongue were also red hot.
Now, actually, what happens is the rivet is normally made of the same material as I gave the example of that vessel in which
Aluminium.
vessel in which the rice is being cooked. Normally, it is a thumb rule that the rivet is made of the same material as the plate. Okay, not of a lesser, not of a material which is of a lesser strength than the plate. That actually was what I meant to. Okay.
Okay, sir.
What material of the rivet you select, that should not be of a lesser strength than the plates that you intend to join, because then that will definitely is not a desired scenario. First of all,
Yes,
your joint will be means if you use a material of the rivet which is having a lower tensile strength compared to the plates that you want to join. So obviously, the weak point is first of all, due to the joining, the part is actually is a weak link. Apart from that, the weak link is further emphasized, or the weak link is further, I would say, means it is made further weak by selecting a material of the rivet of a lesser strength. So a general thumb rule is the rivet should be of the same material of the plate, but it depends also, means based on application. Sometimes you may see that rivets are made of different material than the plates they are used to join. But again, if you use a different material for for a rivet for joining two plates, there is a problem. What is the problem? If you are aware of the galvanic series, are you aware of the galvanic series, the electrochemical series of various materials?
yes, sir.
Some materials are more electronegative, some are more electropositive. So if you select two different materials, so there will be a difference in their electric potential, and that would make a local electrical cell. Okay. Now, what is that electrical cells? Electrical cell are some locally made electrical circuits. Obviously, the circuit is not made by wire, because there are metal to metal contact. So obviously, there can be electrical local cells that can be where electrons are being transferred from one place to the other. So those type of cells, if they are developed due to the difference in electronegativities of the rivet material and the parent material, what will happen is there will be they will give rise to corrosion. Okay, corrosion is nothing but a electrochemical phenomenon. So if corrosion happens, what happens is that will degrade the joint, and that's why if you select a different material, there are special precautions that you need to take into account. There are some special gel type of material are used such that direct contact is avoided. Something like that are done. I am not a very specialist in that field. I've only seen the application for some means systems. Okay, so normally as a thumb rule, if you talk about, the rivet is normally selected of the same material as the base material, not of a material lesser strength than the base material. So here, I guess they have used the same material for making the thing. Looks to be. I'm not sure. Cannot comment directly.
Okay, sir. Sir, understood.
Okay. Any other doubt?
Sir, if we use the rivet material more stronger than the plate material, then when we are heating, instead of deforming the rivet material, the plate material can also deform. If we use rivet material stronger
No,
than plate material.
actually, one thing is, if you see the force path, if you notice the force path is actually not touching the plates directly, because the force is more means mostly taken by the rivet only. When you put this this die on the top and hit the die, the force deforms mainly the rivet. Okay, so that way directly the force is not coming on the plates. But again, as I told you, that selecting a rivet of a higher strength than the base material also depends upon application, and special care needs to be taken while doing that type of riveting. Understood? Just like
Yes.
doing the riveting, obviously you can understand that finally when the head is getting completed, then the force is getting transmitted to the base plate also, and at that time the base plate may get damaged. It is for sure, isn't it? So for that, special skills and special arrangements need to take place. However, again, I am telling that as a general thumb rule, please understand that the rivet material and the base material are normally same. So if you are using two mild steel plates to join, please use a mild steel rivet. If you are using two aluminum plates for joining, please use aluminum rivets. If you are using copper plates to join, please use copper rivets.
Yes.
Got my point?
Yes, sir.
Okay. Next video that I was planning to show you is this one. So this is a pressure vessel. Particularly, I guess this is a boiler. Are you aware of boiler? Anybody is aware of boiler?
Yes, sir.
Yes, sir.
Can tell
Yes, sir.
what is the purpose of a boiler? For boiling water. For boiling
Produce
water.
steam.
For boiling water and
Steam
producing
generation.
steam.
Steam.
That's why the name. It is boiling water and producing the steam. Okay, so that's normally the use means application of boiler, and that's how the name came into existence. And boilers, traditionally, boilers actually were made, means the shell of the boiler, as you can see. If you consider a cylindrical boiler, so the boiler, I don't know whether you are aware of the size of the boiler. You might have seen smaller size of boilers in our department, but boilers can be as huge as the size of a room where people can enter and leave, like train compartment. That much big size it can be there. In power plants there are huge boilers. So if you are making a huge cylinder like that, obviously you cannot make a single component like a cylinder directly made out. You cannot do like that. What you need to do is you need to have a plate like this, and you need to fold, means you need to make the plate turn out like this, and finally you get a cylinder. So this is how you get the cylinder. So as I am talking about making a cylinder from a plate, as you can understand that at one point I have to join the two parts, two end points, two end edges. Otherwise this cylinder will not be in existence, isn't it? So at this joining, normally in the age-old days, now also sometimes it is used, this riveting technique was followed, which is hugely replaced nowadays by welding. Okay, as I told, welding is a more efficient process, efficient joining process. So this, as you can see over here, this is most probably a boiler that they are joining the two sheets like that. They are overlapping the two sheets and they are using the joining, and this is a machine riveting process, as you can see. So I'll just show you. So this is the person who is standing outside the boiler. So there is a person who is sitting inside the boiler supporting the rivet. Otherwise this rivet will go at the other side, right? It is fall inside. So it is not falling inside because some other person is there who is supporting the rivet from inside. So you see, if as I was talking about the practical means perspective, whenever you see a system, try to get have a practical perspective. So here you see they are using this nut and your bolt arrangement, nut or screw arrangement. So can you tell why there is a mix up? Somewhere this rivet and somewhere, and did you see what he exactly did now?
So initially to hold the
Yeah.
round
So
shape in a position.
so that is the thing. So that things are, although they seem to be quite simple, but when you are going to work in the actual field, so these things come into means they are very helpful. So you need to initially, it is easy to talk about like turning the plate and joining it, but when you turn the plate, you need to apply some force, and when you remove the force, this will come out, isn't it? So you need to temporarily hold this until you make the rivet. So what is that temporarily thing? You are using that nut bolt system to hold this two edges together temporarily. So as he is making the rivets from one side, he is going on unscrewing the unscrewing the bolted joints from the other side. So that's how he is gradually proceeding from this right side to the left side. So you see, okay, let me show that the rivet is being inserted from the other side. Yeah, you see the rivet is being inserted from the inside. So the person inside, sitting inside, is riveting it, and with this device, he is hitting, he is providing the impact such that the tail is deformed into this hemispherical shape. So let me show you the person who is sitting inside. Yeah, I guess they have a view. Yeah, they will show now. As you can see, he is actually the person who is inside, and he is also having similar type of device. So that is providing the necessary support, and this side the person is using this device to make this. One typical thing you will notice is that the persons are wearing a what is that, jumbo headset type of thing, that bombastic headset. See, this person is also wearing that. This person is also wearing that. Any idea why they are wearing that? See, I told about, yeah, somebody is trying to tell.
Speaking sound.
Yeah, because this riveting shop always has this sound of impact. Tuck, 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 tuck. Trrr. If it is like a machine, you will hear this type of sound. Trrr, something like that, and it is a very huge sound, by the way. Okay, so if somebody is exposed to those levels of sound, it is I guess more than 150 or around 200 decibel. So definitely they will encounter some problem in hearing. So it is a mandatory thing. I don't know whether it is followed in India or not. Obviously, you can see this is a facility which is situated in abroad. So they maintain all these things very carefully. So normally in a riveted floor, the norm is that the persons who are working there should wear this type of protection. Okay, this is just for protection. They are not hearing any music through Bluetooth from their smartphone. No, this is just from protection from the noise that is being generated.
Sir, I have a question, sir.
Yeah.
Sir, here we can see that the most of the part is covered with riveted joints, but if you can replay it a bit earlier, then we have seen some bolted joints as well. Here. Here. So that means in the boiler, both bolted joints and riveted joints are present.
No. This I just asked a question some time back. No, that why you are seeing this
bolted joint just for support.
Bolted joint is just for holding the plate. The plate should be turned like this, right?
Yeah. Yes.
And now when you turn, it is easy to tell that it is turned like this. But if you remove the force, it will come out. No.
Yes.
So initially, temporarily, you have to hold it. No, until you do complete the riveting process.
Okay. Means for temporary,
temporarily holding the two edges of the plate together. You make the simplest way to is use bolt and rivet, isn't it?
Yes,
so that's why they are using that. You see from the right side continuously they are going on riveting, and there if you see here, that person is actually removing, you see removing the bolt. So he's going on removing the bolts and adding the rivets like that. from the right to the left. So that's why this bolted joint. Obviously, for a boiler, the leak proofness is a very serious thing. You need to have the boiler leak proof. Otherwise, if you plan the pressure of the steam to be of some megapascal, and if there is leakage, so you will never be attaining that amount of pressure. And this bolt and screw joint is are not quite effective in providing this leak proof type of joint. So that's why these are just for temporarily holding the.
Okay, sir. Thank you.
At any point of your means, I guess you are having some internship program, and at any point, if you happen to go to a riveting shop, so you will find that this type of thing, they wear this protective devices, and you will hear that noise also from very far away. You will hear these noises, and you will understand, okay, their riveting shop is there. Okay, anything else? What is this?
So for leak-proof joint, we prefer riveted joint than welding joint, or welding joint is better?
No, welding joint, as I told, welding joint can provide a good amount of leak proofness, and welding joint has an added advantage of having higher efficiency compared to riveted joint. That's why means nowadays your welding joint is taking over the riveted joints, you may say. আজকালকার দিনে রিভেটেড জয়েন্ট খুব একটা হয় না, মানে বেশিরভাগ ওয়েল্ডেড জয়েন্ট দিয়েই করে নেওয়া হচ্ছে। ইনফ্যাক্ট in our laboratory, means in our department, okay, actually I am working with means what I'm trying to tell is welding process has seen a huge development. Okay, so there are various sophisticated welding techniques that have now means known to mankind, and one of them we are having right in our university, that is known as friction stir welding. So in friction stir welding, we can achieve efficiency higher than 100%. Efficiency is normally termed in percentage. So 100% efficiency means greater than 100% efficiency means the joint is of a greater strength than the parent material. I guess you can understand by the very first discussion that I had in the towards the beginning of the class. Higher than 100%. Mane tensile specimen, if you make, in fact, what we have done is we have cut out a tensile specimen. At the midpoint is the welded joint. So when you pull the tensile specimen, it is expected that from the mid portion it will fail because that is the joint. But contrary, the specimen failed from some other portion in the gauge length. So that indicates the welded joint is has become stronger than the base material, and that is possible due to the grain refinement. I am not sure whether you are aware of this grain boundaries, crystallization. So some this
yes, material science is already
material science পড়ানো হয়েছিল, right? So this if you are dealing with finer grains, so that actually enhances the strength of the material, so rather than having a coarse grain structure. So those type of welding process that I was just referring to, they promote that fine grained structure in the material, and hence it is found that the joint is more strengthier than the parent material. So that's why, due to this development in the welding technology, they are now gradually replacing this riveting process. আচ্ছা, এটা কি করছে? Okay, here they are actually showing that first you make the hole, everything actually. This is the rivet. So this is a single integrated device. So one side is the backup bar and this side is the other bar where it is hitting. I guess you are finding these videos interesting, right? I like to show the videos.
Yes, sir.
Yes, sir.
Simply teaching makes the job very boring, isn't it? For you as well as for me.
Yes, sir. And we also are not having the workshop because of the pandemic.
Oh, okay, right. Okay. Oh, definitely. So you need to see these videos, right?
Yes.
However, I am not sure whether in the workshop curriculum they show welding, show this riveting. Welding is definitely there. Riveting.
Yes, the welding was there, but we are not able to do that classes.
Okay, right. Anything else? Let me show this.
Sir, welding is Sir, riveting is too much cost effective than welding, right? Riveting costs
কস্ট এফেক্টিভ
রিভেটিং এর
হাউ?
কস্টটা অনেক কম ওয়েল্ডিং এর থেকে আই গেস, মানে সেটা তো তাহলে বেশি ব্যবহার হওয়া উচিত ওয়েল্ডিং এর থেকে।
কস্ট এফেক্টিভনেস যে তুমি বললে মানে কস্ট কম, দেন তোমার কস্টটা কি খালি রিভেটের মানে কস্টটাই ধরবে, বা ইকুইপমেন্ট যেটা দিয়ে আমি মানে ধরো প্রসেসটা ক্যারি আউট করছি সেটার কস্টটাই কি ধরবে? সেটা যদি কস্ট ধরো তাহলে ঠিক আছে, আমি মানলাম যে রিভেটের কস্টটা কম, ওয়েল্ডিং এর জন্য আমার সফিস্টিকেটেড ফেসিলিটি দরকার, হায়ার সেটআপ কস্ট দরকার, মানছি, হতে পারে। কিন্তু ধরো আমার যদি জয়েন্টটা ফেল করে যায়, ধরো রিভেট দিয়ে করলাম, ধরো 2 বছর পরে জয়েন্ট ফেল করে গেল, তার মানে আমার সিস্টেমটা ইউজলেস হয়ে গেল, আমার ব্রেকডাউন পিরিয়ড চলে গেল, আমার লস অফ ম্যান আওয়ার হয়ে গেল। কিন্তু ওয়েল্ডেড জয়েন্টে হয়তো সেম সিস্টেমটা আমার 8 বছর করলো, বুঝতে পারলে? তাহলে সেই ক্ষেত্রে এবার তুমি ক্যালকুলেট করো, এবার তোমাকে ওই ম্যান আওয়ার মানে পুরোটা এবার তুমি বুঝতে পারবে, পুরো সিস্টেম তোমাকে ক্যালকুলেট করতে হবে। এন্ড দিস ইজ পার্ট অফ দ্য লাইফ সাইকেল অ্যানালিসিস, মানে ফ্রম দ্য ক্রেডেল টু দ্য গ্রেভ। ক্রেডেল মানে বোঝো তো, মানে যখন বাচ্চা baby
Dulma.
are kept on the cradle, and finally what happens is for a typical human being, from the cradle gradually he goes older, age old, then finally dies, expires. So after that in the grave. So cradle to grave, this analysis is known as life cycle analysis, which is gaining relevancy nowadays, because খালি একটা পার্টের কস্ট দেখলে হবে না, পুরো সিস্টেমের কস্ট দেখতে হবে, পুরো লাইফ সাইকেল অ্যানালিসিস করতে হবে, তবে গিয়ে কস্ট এফেক্টিভনেসটা আসবে। বোঝাতে পারলাম?
হ্যাঁ হ্যাঁ বুঝতে পেরেছি।
হ্যাঁ, তো সেই পার্সপেক্টিভ দিয়ে দেখলে দেখা যাবে, যদি আমি লাইফ সাইকেল অ্যানালিসিস নিজে তো আমি করিনি, আমার সেই অর্থে লাইফ সাইকেল অ্যানালিসিস এর এখনো কাজ আমি করে উঠতে সেই অর্থে পারিনি। আই হ্যাভ এ প্ল্যান দ্যাট আমি ফিউচারে হয়তো করব। তো সেই অর্থে দেখা যাবে যে হয়তো তোমার ওয়েল্ডিং জয়েন্ট ইজ মোর মানে কস্ট এফেক্টিভ কম্পেয়ার টু রিভেটিং জয়েন্ট।
আচ্ছা বুঝতে পেরেছি।
আচ্ছা, এখানে কি কিছু নতুন দেখাচ্ছে? এখানে খালি লোকটার ভুঁড়ি ছাড়া তো কিছুই দেখা যাচ্ছে না। Oh, same thing actually, nothing. First you have those the joint temporarily in place by the help of this nut bolt system, then you do the riveting. আচ্ছা আচ্ছা, অনেকটা টাইম হয়ে গেল, আর 10 মিনিট আমি ম্যাক্সিমাম নেবো, ঠিক আছে? আচ্ছা, okay, this was done. Okay, rivet heads can be of many types. So as you can see in the picture, there are various heads, and each of these heads depend on particular application, মানে for which application which head is suitable, accordingly you have to select those heads. So this is the normal head that we see, and it is known as the snap head. Then there is this pan head, which is like this trapezoid type of thing. Then it is a mushroom head, flat, hemispherical. Then countersunk, I guess you know the utility of countersunk. Countersunk bolt is also there. Countersunk means okay, let me show you by having the picture. If I am having Google Y2 countersunk, was bolt to understand in a moment. So you see the head is like this. So the advantage of having countersunk head is the hole is also made in countersunk format. If I zoom this, so the hole, as you can see, is not a typical hole. It is having a larger like this means hole to accommodate the head of the screw. Then the hole is there. The normal cylindrical hole is there. So the advantage of having countersunk arrangement is you don't have protruding head. In some of the systems, if you have the head protruding out of the surface, and suppose the system is moving at a very high speed, so something may get stuck and some accident may be caused. So in order to avoid that, you need this countersunk type of arrangement. Besides, if you think that some other part is there which should mate on this surface, there are two objects which should mate on this surface. So if it is about, if you talk about mating, then you need a perfectly flat surface. You cannot have any projection outside. So in those type of systems also, this countersunk arrangement is useful. So in a particular application where you need this countersunk arrangement, so these are the countersunk various type of countersunk rivets. Similarly, you have a flat head. So flathead is, I am aware of flathead. Flathead is normally used for joining two sheets of various of very less thickness, like sheets of thickness like Almira sheets you might have seen, right? Almira is made of sheet metal. So those type of sheet metal work, normally these flathead rivets are used. I think I have some of the examples here. Snaphead is more popular in boiler, pressure vessel, and general engineering application. Panhead is used in boilers and ship hulls. So the ship bodies also means initially it was made of rivets. So in those cases, panhead is more suitable. Countersunk to bolei dila. So these are the desirable properties of rivet. It should be free from cracks. It should not have flaws like means any defect should not be there. The head should be concentric with the shank. This head and the shank should be concentric. So obviously, if it is not concentric, so there it may give rise to some defects. So those things should be taken care of. আচ্ছা, এইগুলোতে আর যাব না, এই অবধিই থাক, আজকে আর বেশি ড্র্যাগ করছি না। Tell me if you have any doubt, anything. Next day we will start from the next slide and we'll continue. So in our rivet we have the design of the rivets, and we also have the manufacturing of the pressure vessel with the help of riveted joints. So there is a body which is known as IBR. Actually it's not a body, it's more of a act or a regulation. It is known as Indian Boiler Regulation. So that regulation is actually defining the various ways the boilers should be joined with the help of rivets. So that particular document gives the rules and regulations of making the riveted joints with the boiler, for boilers and pressure vessels. So that IBR, following IBR, we have that design philosophy of this boiler shells, and that also is there in this riveted joint chapter. So that we will subsequently address. Tell me, any doubt, anything, any part of the thing you could not understand, you could not get? I normally don't like to drag the lecture beyond 1.5 hours, because I feel after that the keeping the attention of the students is difficult. So that way I try to complete a particular class within 1.5 hours. বলো, কেউ কিছু বলবে? Any general comment you want to make? যা বললাম, whatever I had told today, did you understand? Any doubt regarding that? The process you understood, right?
Yes, sir.
The examples you understood,
Yes,
whatever
sir.
example I tried to give.
Yes, sir. Yes, sir.
Okay. So that is the thing. So shall we end for today then? I'll share this lecture video once I create the Google Classroom. You will find this lecture video there.